Our next speaker is Reema Shafi, who's a PhD candidate at the Rehab Science Institute, University of Toronto. Her research interests lie in understanding the functional organization of large-scale neural networks, investigating the influence of sex on alterations in neural organization post-injury, and examining the implications for rehab, such as resuming day-to-day activities and returning to employment. Additionally, her current research project is exploring the intersection of traumatic brain injury and neurodegeneration in women survivors of intimate partner violence. Her research is supported by the CIHR, Canadian Concussion Centre, and the Women's College Hospital. Reema.
Okay, so the topic of my talk today, I know I'm going to run over by a couple of minutes, so I apologize ahead of time. The topic of my talk is sex-specific alterations of the salient frontoparietal networks in individuals with post-concussion symptoms. In the interest of time, I will spare the slides on epidemiology and biomechanical consequences of concussion. So we were interested in exploring functional connectivity difference in the PCS population. Functional connectivity is defined as the correlation between spatially remote neurophysiological events, or in simpler words, spontaneous data is acquired. Regions of the brain are correlated based on percent change in bold oxygenation levels, and the correlated groups are, correlated brain regions are grouped together as functional networks, and these networks enable us to understand and predict brain architecture and predict behavior and function as a result. Given that there are no objective measures to detect concussion, resting state networks are a means to characterize and understand the impact of concussion, impact of concussion on the brain. So we conceptualized our study based on the triple network model that was proposed by Vinod Menon from Stanford to help provide a common framework for understanding dysfunction. There are three networks in the model: the default mode network, which plays an important role in monitoring the mental landscape. It is a prominent resting state network that is deactivated during stimulus-driven activity. The salience network is thought to play a role in detecting and orienting the stimuli, both in the internal and external environment, and is responsible for engaging attentional networks such as the frontoparietal network. The frontoparietal plays a role in the higher order cognitive functions and taps into domain-specific cortical regions to do that. Again, in the interest of time, I'm just going to present a painfully simplistic consolidation of the evidence. We know that in the acute stages of concussion, there is an increase in frontal activation patterns, but there is overwhelming support that there is reduced default mode connectivity, but there is recovery over time. Within the chronic stages, however, it's been reported that there is increased connectivity between the default mode network and the frontoparietal network, and between the saliency and globally prosyllated regions of interest. There is evidence with respect to sex-based differences in brain architecture, but there is limited empirical evidence when you're looking at sex-based alterations post-concussion. There is only one study to date that has reported a female disadvantage post-concussion, and they report a persistent state of hypoactivation in a 6-week follow-up along the frontal and parietal regions when people were participating in a working memory task. The evidence related to structural connectivity is mixed. One study reporting a male disadvantage pertaining to the enunciate fasciculus, and others citing a global female disadvantage to long projection fiber tracts such as the superior longitudinal fasciculus. Oh, sorry. Is that better? Okay. So which brings us to the aims of our study, which were to examine the intra- and inter-network connectivity patterns of large-scale networks, and to explore the functional connectivity post-concussion by sex. We hypothesized that concussed participants would have increased within and between network resting state functional connectivity when compared to controls, and that there would be sex-specific differences in network connectivity post-concussion. This was a cross-sectional design, a secondary analysis of data. There was an age and concussion-specific eligibility criteria. People had to have sustained one concussion, had to be symptomatic after the concussion, and the symptoms had to persist for a minimum of 3 months post-injury. The exclusion criteria was if they fell outside of the eligibility range, and if the injury was more severe than a concussion, or if there were pathological findings in the MRI scan. A 3T imaging protocol was employed with a 4-pulse sequence. We were, of course, interested in the bold signal, and the data was analyzed using a standard connectivity toolbox. We had a sample of 111 participants, 80 concussed and 31 controls. There were no statistically significant differences between groups based on sex, age, and education. Males had an increased number of prior concussions compared to females. However, not only was that difference not significant, we had a good effect size. And the average time since concussion was 19 months post-injury. So here I've just presented a schematic of where different nodes for the networks were, just to provide a graphical representation. We had 4 nodes from the default mode network, 7 from the saliency, and 4 from the frontoparietal network. So I'll first present the network connectivity-based results. And the connectivity map that you're looking at is a contrast between patients and controls. The red lines represent increased connectivity, and the blue lines represent reduced connectivity. And what we see in our sample was an increased connectivity between the salience and the frontoparietal networks in the concussed participants compared to the controls, and that this increased connectivity was localized to the frontal nodes of both networks. We're interpreting this as a hypervigilant frontoinsular state post-concussion. In addition to the increased connectivity, we saw reduced connectivity between the parietal nodes of the saliency network to all 4 nodes of the frontoparietal network, both frontal and parietal. And we're interpreting that as a parietal interference across all nodes of the frontoparietal network, perhaps in lieu of the hyperactivity that we've seen earlier with the frontoinsular cortices. We did not find any group differences with respect to the default mode network, which the literature has shown. We don't see that in our sample, and we did not find any sex-specific differences within network-based connectivity. We did explore network-to-region connectivity, and one of our most interesting findings was when we explored the injury by sex interaction. This increased connectivity was observed from the node of the frontoparietal network to the temporal regions, including the superior temporal gyrus and the planum temporale. And when exploring the interaction during post-hoc analysis, we see that while the connectivity strength is increased in females at baseline, there is a significantly reduced functional connectivity in females in the concussed population relative to both male concussed and controls. And that the magnitude of the effect is greater in females, ranging from a positive value in controls to a negative value in the PCS population. We find this result really interesting. But again, in the interest of time, I'll try and list 3 points that I feel are relevant. So we know that the superior temporal gyrus is implied to play a role in functional switching of auditory attention, commonly known as the cocktail party effect. And we've heard that twice in this symposium. It is the brain's intrinsic ability to focus on the auditory stimulus of interest and to be able to filter out other stimuli that are in your environment. And this reduced functional connectivity in the concussed females may indicate that the networks are unable to recruit, or the frontoparietal network is unable to recruit certain cortical association regions due to a hypervigilant frontoinsular component. We also know that there are well-established we know that the temporal cortex is sexually dimorphic, so we know that there are sex differences within hemispheres and there are asymmetries. We know there's a stronger leftward asymmetry in the temporal regions in males compared to females. Females have a large volume in the right temporal cortex, but not the left. So these results may indicate that certain brain regions have a sex-specific vulnerability in the impact for concussion, more so in the females within the temporal cortex. We also know that there are sex-specific structural disadvantages in axonal microstructure that have been demonstrated more recently and present as a susceptibility to injury in females in particular. We did have, like any study, strengths and limitations. We had a considerably large sample compared to all the other fMRI studies on concussion in the chronic stage. We did have a control group. We did best practices by stratifying the data and analyzing them. And we had a spectrum of chronic stages of recovery, which really helps fill the void that we have in terms of understanding network connectivity in the chronic stages. We did have a selection bias. The concussions were self-reported, so we had no objective measure of quantifying them. And we did have lack of hormonal and functional activity-related data in the population. So just to summarize, it appears to be a hypervigilant saliency network that reflects alterations in cortical processing within neural networks. Both frontal and parietal influences may affect hierarchical processing across association cortical regions, and to highlight that sex-based alterations in functional connectivity should be explored to better understand sex-specific changes post-trauma. I do want to acknowledge my academic supervisor, Angela Colantonio, and my mentor, Dr. Adrian Crawley, who has taught me everything I know about imaging today, and particularly the Canadian Concussion Centre for their support. Thank you.
What do you mean by the cocktail party effect? And is there any other symptom that can be related to your findings? Like what do your findings mean in terms of symptoms that patients experience?
Right, so I didn't have time to talk about the extent of it. So we haven't explored neuropsych, which we are hoping we will. What we know about reported symptoms is they report headaches, dizziness, and those PCS-related symptoms, but we don't know much about how the temporal gyrus might be related with the cocktail party effect. It is a symptom you see very often in MTBI, in concussion, in the clinical setting. So we're hypothesizing that that's what the effect is. We have yet to look at the neuropsych.
I was just wondering, what was the connectivity strength for your groups?
What do you mean?
Like, they give you a strength, like it ranges from, I think, a negative number to a positive number?
Right, so it was a slight shift from positive to negative. It was plus minus 2 in terms of the Fisher Z score.
Oh, okay.
Yeah. Thanks.